Okay, so the last thing we're going to do is to make a box plot. I know I sent you a link to a video that you could watch yesterday on how to do it, but I thought I'd take the data that we collected yesterday and demo that and then ask you a few questions about it. So over here on the left-hand side of the screen, I just gave you guys the letters, the students that took the Stroop effect data test. So the easy one was the first time you did it where the color and the word actually matched each other. So the word pink was the color pink. The second one, the harder one, I should call that harder, was the one where you were trying to read the color of the different words, but the word name and the color didn't match. So like when you said uh, green as the color of the word, the word might have actually been red. So that was a little trickier. All right, so a box plot is different than a line plot and a histogram in that it really shows you how spread out the data is and how it kind of clusters, okay? So the first thing you need to do to make a box plot is I'm going to go turn my paper sort of sideways. It'll sort of help me use this line and some things to set it up. But the first thing you're going to do is you're going to put the data in order. So these are the numbers that I had. I had 20, 35, 19, 17, 16, 16, 28, and 17. I'm going to go ahead and put those in order. So let me see. 8 would be my first one, and then 16 is the next time. Add another 16, two 17s, a 19, two 20s, oops, and a 35. Okay, so let's just double check I've got the right amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how much data I collected yesterday at the time when I pulled the data. Okay, so I've got 9 numbers. What you're going to do is find what's called the 5-number summary. That consists of basically the median of the data. So you're just going to find the middle number, or if there's not one that's in the middle, remember we did medians back a while ago, then you'll take the halfway between those two numbers, and then you're going to find the median of the top half of the data, the bottom half of the data, and then the extremes. Okay, so first I'm going to find the middle of the data. I'm just going to say 1, 1, 2, 2, 3, 3, 4, 4. Okay, so 17, this is my median. That was in the middle. Then I can double check this. I've got 4 numbers here and 4 numbers here. Now, if there had been 10 numbers, like let's say this was a 40 up here, then my middle would be between 17 and 19, and I would have used 18, okay? All right, but I actually had a median, okay? If I had to go in between, then I would find the lower quartile would be the median of the bottom half, the upper quartile would be the median of the top half, okay? So, but since 17 is neither part of the top or the bottom, I'm not going to use it in calculating the quartiles. All right, so I want the median of the bottom half. So I'm going to go 1, 1, 2, 2. Okay, it's between these two 16s, and the halfway point between two 16s would just stay 16. Okay, and then done. Okay, it's going to be 20 here. So my 5-number summary, my minimum or lower extreme. Okay, the min is going to be 8. The lower quartile, the median, the bottom half is going to be 16. My median is 17. My upper quartile, median at the top is 20. And my upper extreme or max can be called either as 35. So those are the only 5 numbers I'm going to actually graph. Okay. All right, so what I'd like you to do is see if you can do that same thing for the harder list of numbers. So put them in order, and then you're going to find the median, the upper and lower quartiles, so the median at the top and the bottom, and then try and find the extremes. Okay, so did you start by just thinking about what was in the list? I've got 40, 57, 27, 56, 47, 50, 120, 16, and 55. Okay, I'm going to start by putting them in order. So it looks like somebody actually was able to do it in 16 seconds. Wow. Okay, so then next I've got a 27. Okay, and let's see, 40, and then I've got 47. Okay, 50, my 55, 56, 57, and my 120. Okay, so let's just double check. Do I have my 9 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. I do. Okay, so I'm going to go find my median. So 1, 1, 2, 2, 3, 3, 4, 4, 5. My median is 50. Okay. All right, then I'm going to find my median of my bottom half. 1, 1, 2, 2. Okay, and if you just want, we're not sure real quickly how to find the middle between 27 and 40, you can just add them together and then basically find the average. So 27 plus 40 is 67. When you divide them by 2, did you get that? It was 33.5. So 33.5 would be the median down here, the lower quartile. All right, and then median of the top half, what's halfway between those would be 56.5. All right, so what am I going to plot here? My minimum is 16. My lower quartile is, let's see, 33.5. My median is 50. My upper quartile, 56.5. And my max, my upper extreme, was 120. Okay, so now I've got my 5-number summary. Those are the 5 numbers I'm going to need to plot to make my box plot. All right, so really the objective for 7th grade is that you're using these different types of graphs to actually compare 2 data sets. So I'm going to graph them both on the same scale. So all you need to do is come up with kind of a number line down here. And it looks like my minimum was 8, and then my max 120. So maybe I'll just start at 0 and count by tens. Okay, I have a block. I think I can get that to fit. So 10, 40. So I guess I'm really counting by 5s. Okay. All right, so then I will demo how to graph the first set. Okay, so all you're going to do is you're going to put a dot at each of these. Okay, so I'm going to go across a dot at 8, a dot at 16, so this is 15, so 16, dot at 17, dot at 20, and at 35. Okay, so I only plot these 5 numbers. Okay, and then I'm going to make a box. I'm going to use 3 lines with my 3 middle dots and make a box out of that. And then it's called a box and whisker because then I make a whisker between those. Okay, so you take your 5 numbers, make a box out of the middle 3, and then whiskers till the end. Okay. So I want you to go ahead and try and see if you can plot those on the number line. Just do it below here. So this was our the easy test. Okay, and I want you to plot the hard one below it. Okay, so how'd it go? Did you put a dot at 16? At 35, so 33.5 about here. 50, 56, and then 120. Okay, so and then just again, here's what I plotted with 16 here, 33.5, my 50 was here, 56.5, and then 120. Okay, this was 8, 16, 17, 20, and 35. Okay, so it just kind of shows how spread out our data is and kind of makes a few things we can compare. Okay, so I'm going to go ahead and just ask you, what are some things that you noticed about this data? Okay, so did you notice that when you guys took it the first time, most of your students, it was pretty compact here. So we had sort of similar amounts of time that it took many of you guys to just read through the color words. Okay, but there was a student that after they did this, they said that they were colorblind. So it was a little, um, the, you know, reading the words with this whole thing wasn't super easy. Okay, so because they couldn't just rely on the color, they really had to just focus on trying to read the word. Okay, so what student do you think maybe that was? So was that one of these guys? Said that they were colorblind, so actually having the color didn't help them read the words any faster. Okay. All right, so did you think that was person B that took them 35 seconds to do it? Okay. All right, so and if you look at the second set of data, what do you notice that, did we have more students the second time around, or why is this plot so much like longer? Okay, did you just say we had a bigger range of scores? Okay, so somebody must have been able to zip through this, that they had this in 16 seconds. So, but most of the rest of you guys, it took closer to, in the 40s and 50s or so, this area. So kind of spread out. So we had a lot more range or different amounts of time that it took us the second time. And then somebody took a pretty long time. Okay, what student was that? To look over here, which student took a really long time to finish this test? Okay, did you say student G? Okay, with that 120. Okay, so hopefully after working through this activity, you have an idea of what a box and whisker plot is and how it can be used to make comparisons between two sets of data. So it really just shows how compact or how spread out the data is.